If you're brand new to CNC, one of the hardest parts is not learning the software or learning the machine, it's understanding how the whole process fits together. How do you go from a blank screen in the design software to creating toolpaths, to setting up the CNC, to actually cutting a finished project? We're gonna make a simple custom tray that can also be used as a coaster. And we're gonna personalize it by carving an initial in the bottom. And this is a great beginner project because we're keeping it simple. We're only going to be using 1 bit, a 1/4 inch end mill, and we're going to be using 2 of the most common toolpaths, a pocket toolpath and a profile toolpath. I'll also be cutting this project out of insulation foam board first, which is a great practice material because it's inexpensive, easy to cut, and much more forgiving than wood. You can absolutely use wood if you're ready for that, but if you're nervous about making your first cut, foam is a great way to build confidence. I will also show you a technique I like to call running a ghost toolpath. And that's where we run the CNC above the surface first so you can watch how the machine moves before actually cutting into the material. For this video, I'll be using Vectric Aspire for the design and the toolpaths, but because this project is very simple, you can follow along with Aspire, VCarve, or even Cut2D, and everything I show you will be exactly the same. And then for the machining portion, I'll be using a Onefinity Elite Gen 2 with the Redline controller. Your machine and controller may look a little different, but the basic workflow will still apply. So the goal of this video is not to make the most complicated CNC project possible. The goal is to help you understand the complete beginner workflow from start to finish, so you can get that first win and feel more confident using your CNC. And if you ever want to go much deeper into Vectric after this, I'll also tell you more at the end of this video. So let's jump into Vectric and start designing our first CNC project. The first step is to create the design inside of Vectric. Before we think about cutting anything on the CNC, we need to create the vectors that tell the software what shape we want the project to be, where the pocket will go, and where we want to place the initial. For this project, I'm going to be keeping the design simple, but I still want to encourage you to make it your own. One of the biggest advantages of having a CNC is that you're not limited to basic rectangles and circles. You can create custom shapes that would be much harder to make with normal woodworking tools. So let's start by setting up the job and creating the design for our custom tray. Okay, so here we are in our Vectric software. Like I said, I'm using Aspire, but no matter which platform you're using, all the buttons are going to be exactly the same. So we're going to go ahead and first create a new file by clicking the button here. And that's going to open up your job setup. And the very first thing we're going to do is set it up as a single-sided job. That's the most basic and easiest way to machine things on one single side. And then we're going to set up our job size. So this is going to match the material size that you have for this project. I'm going to be using the foam board that I mentioned in our intro, and that's going to be this foam material here. If you're using the same exact material, you can copy what I have here. If you have a different material, make sure you measure it very accurately and enter in those dimensions here, especially the thickness. You want to make sure that's very accurate. So we're going to go ahead and enter that in here now. The sheet I have is 24 inches wide by 24 inches tall, and it is 1 inch in thickness. That is the foam board. Like I said, if you're using different size material, please adjust these numbers to match. Next, we have to specify what zero positions we want to use. These are all personal preference. You can select wherever you want to. The main thing here is we have to match whatever we do here when we zero our tools on the machine. And we'll be showing that in the machining side of things. So make sure whatever you select here, you actually match it on the machine. If you want to follow along with me in the videos, I recommend going with the material surface, since we're going to be machining a lot of the surface of this material, and we're going to zero off the lower left corner. Those are pretty common zero locations that you can choose. And you can always change these if you want to, just make sure you match them on your machine. But to keep things easy, you can follow along what I have here. Up next, we have modeling resolution. This does not really matter because we're not 3D modeling. So we just keep that as standard. And down here where it says material settings, that does not matter as well. This is just what it looks like in the 3D view. It does not change anything in your project. So you can skip that as well. Unless you want to play around with that, you can. But we're going to click OK. And that's going to bring us into our project. And right here on the left-hand panel is all of our design tools. So this side, we're going to do all of our designing. And then in the next step, we're going to be creating the toolpaths. So that'll be on our other side. Let's stick with the design for now. So this custom shape that I made for this tray
You can see it looks quite complicated when you look at it, but honestly, if you break it down, it is just two rectangles with rounded corners, and one is rotated 45 degrees. That's how I would see this shape, and that's how I would create it inside of Vectric. I'm going to show you how to do that. Before we do that though, I do want to show you there is a what's called a clip art tab here. You click on that. Inside of here, there's a folder called 2D Vectors. And if you search in here, you'll find many different shapes that are already ready to go. You'll see they do have a panel number 8 that is very similar to this design. You can use that if you don't want to spend the time to create it yourself, or you can go in here and select a different shape that you may like. Maybe this one here, panel 84, is a pretty cool looking shape as well. So you can go through there and select which one you like. Just remember to scale it to the size that you want it to. But that's just a little bit of a shortcut. I want to show you how to actually make the shape yourself, because that's the whole point of this. You want to be able to make things yourself. So it's not always best to rely on things like this, because if you have the skills to make it yourself, you can make anything. So let's go back to the design tab. And like I mentioned, we're going to be using the draw rectangle tool. So to define that, you're going to go to the create vectors area, and there's going to be a draw rectangle tool. You're going to click on that, and up here at the anchor point, this is just going to be where it's going to be placed in your job. And you can snap to any point here. We're not going to get into all the details here, just to keep things simple. But the main thing we want here is the size, and we're going to put a radius corner on here as well. We're going to do a radius external corner. That's going to radius the corners of the rectangle. And you could specify the radius, but I'm going to put 1/2 inch for this. And then for the size of the rectangle, the width, I'm going to make it 4.25. And then for the height, we're going to make it the same, 4.25. And of course, you can adjust these dimensions if you like, but these are the dimensions we're going to go with for our project. And now we're going to either click on the screen where you want to place it, or you can type in an exact location here where it says anchor point. I'm just going to click down here because we're going to move this later anyway. So I'm just going to click right here and put it somewhere near the corner. And then we're going to create one more because these are going to be two rectangles we're going to combine together. So I'm just going to click on the screen again to place our second one. And these are just random clicks on the screen just to place them there for now. Now we're going to click close to get outside of our rectangle tool. So here we have two rectangles created, and now we need to combine these together, and we need to align them on top of each other. So for one of these rectangles, we're going to rotate it 45 degrees, and that's going to create the effect that we have for this shape. So to do that, you can use your rotate tool, but I'll also show you there's a quick shortcut key, the number 9 or the number 0. Those will rotate at 45 degrees. One will go clockwise, one will go counterclockwise. So those are just quick, easy shortcuts to use. But if you don't know the shortcuts, you can always go to transform objects here and find your rotate tool. Also, the letter R will open this up. You can see that there. And here we're going to select that rectangle and then just type our angle 45 degrees, click apply, and then click close. Now this has been rotated 45 degrees. Now we can put them on top of each other to be able to combine them together into one shape. And in order to align them together, you could double click on one and try to manually move it. And if you have your snap settings turned on in the upper right corner, you could snap it directly right there on top of each other and have it perfectly centered. That may take a little while to get used to and to try to get it just right. So I'm going to show you another way by using our alignment tool. Once again, that's in transform objects. It's going to be this last one here. So we're going to select that last one. That's going to be our alignment tool. And we have a couple options in here. We're going to be using the align to selection, and you can see it'll align the selected objects to the last item in the selection. And we can choose this center one here to center it. So we're going to select this one on top, and then we're going to hold shift and select the one on the bottom. So we just selected both of those, and the one on the bottom is the last one selected. So now we're going to click that center button, and you'll see that aligns it perfectly centered on top of that last one. Now we can click close, and now these are ready to be combined together into one shape. So as you can see here, when you're creating shapes, you're going to use shapes in this create vector section. When you are altering shapes, you're going to use this transform objects section. If you want to move, rotate, or align them, or even scale them to different size. And then down here, next, we're going to edit them. So we have two shapes we're going to edit together, and we're going to be using this weld tool. So in order to use that tool, we have to select both of these vectors. You can draw a selection box around them, or you can hold shift and select them both. And then in Edit Object, you're going to click this Weld button. Click that now, and you'll see it automatically welds them together into one shape. And that is our custom shape we're going to be using for this project. Now there's one more thing I want to do here, and that is going to be put a little bit of a radius on these internal corners as well. And that's going to be able to match these external radiuses that we made earlier. So in order to do this, we need to use one more tool, and that's going to be, once again, in the Edit Objects. It's this one right here called Fillet. You click on that. This will give you a few options. First, we need to enter a radius. So we're going to enter 1/2 inch to match the radius we did before. And we're going to select normal fillet. Now you just need to hover over those corners and click on them. And you'll see when you do that, it'll put a fillet in those corners to make that a radius. So you'll have to do that for all 8 of these corners. And once you do that, this shape will now be complete. And we can click close. And now we have a nice closed vector that we're going to be using for our profile of this toolpath. Now that we have that created, we can go ahead and focus on the next part, which is going to be the internal shape for the internal pocket. We have the external shape for the profile, and then we're going to have an internal shape for the pocket area. That's going to be important, so that you do not have to go ahead and spend all the time we just did to do that again. There's a really simple way to do that. You just select this shape that we already made once it's done, and then you're going to go ahead and go down here to the bottom where it says Offset and Layout. You're going to choose the Offset tool. This tool will allow you to take a shape and offset it inwards or out, or even both. So in this case, we're going to go inwards, and the amount we're going to go is 1/4 inch. So you're going to select inwards and type in 0.25, and then you don't have to select any options down here. You can keep that blank. And now we're going to click Offset. And when you do that, now you can see it took that original shape and made an offset. And now we have a new shape inside of here that we're going to use for our pocket. So that's the second shape we need. The very last shape we need is going to be our initial for the bottom. This part is optional, but if you want to customize it a little bit for yourself, or you can even put a heart or something at the bottom, whatever shape you want to put there, feel free to go ahead and customize that for yourself. But if you want to use your initial, what I recommend doing is going to the Draw Text tool. So this will be a new shape we're creating. So we're going to go to the Create Vectors area, and we're going to click on this Draw Text icon here. And for this one, choose the text option at the top. This will be just a normal text. And you're going to type in the text that you want to engrave at the bottom. Now, the reason I'm not engraving a full name in here is because we're using a single tool, and that 1/4 inch end mill that we're using can only fit in certain shapes. So if you do really small text here, you're going to have to use a separate bit for that. So to keep things simple, we're going to create just one letter, and that way we can use one single tool for this whole project. So for this, I'm going to type in the first letter of my name, which is the letter K. And when you type that, it might show up randomly on the screen. So you can always click and drag it to move it where you want to. And like I said, if you have the snap settings turned on in the top right corner, you should be able to click and drag the center of this, and it will snap to the center of that project there. If it doesn't snap, you can use the alignment method that we showed in the previous steps. So now that we have that there in the center, the next thing we're going to do is choose our font. So that's going to be this next drop down here. You can scroll through these and look through which one you want. However, keep in mind the tool has to fit inside of this font. So a font I'm going to recommend for this is called Arial Rounded MT Bold. So this is a nice rounded shape with a bold font that's going to be pretty easy for most bits to get into. So I'm going to choose that one there. You can also choose the bold option here to make it a little bit more bold if you wanted to, but that's really not necessary. And then the next thing we need to do is adjust the text height. Also, I recommend keeping the alignment centered so the text stays centered. And then for the text height, I'm going to type in 3 inches here, and then that will adjust it. And once you adjust the height, you might have to adjust the position a little bit. So I'm going to move that back down and snap it center there. If you're not sure about getting it snap centered, you can always move it out of the way and then grab the center point of the letter and drag until you see a bullseye right in the center of your project there. That'll snap there, and then let it go. Now we are nice and centered there, and we can click close. Now we have all the shapes we need to create this project. And as you can see, a very simple and easy to make project. And I highly recommend saving this project at this point before we go any further, because Vectric does not auto save. So if you want to avoid losing your progress, this is a good time to save. And you always want to save as early as you can and as often as you can. So to do that, you can click File, Save. Now we'll save your project. And I am just going to name this initial tray. And then we're going to click save. So this has now been saved. And at this point, the last thing we need to do is move this into the location where we want it to machine. So wherever you place this on this white area, that's where it's going to machine into your material, because this is the size of our material. So if I move this to the center here, this will now machine into the center of our material. But as you can see, there's a lot of waste out here. So I don't want to waste all of that material there. So I'm going to move this down into this lower corner. That way I have extra material here to use for a different project. And if you want to be precise with this location, you can use the move tool. And that's, once again, in transform objects, going to be the very first one there. You can also use the letter M to open that tool up. You want to make sure you select all of the objects so you can draw a selection box around them, or you can also right click and click select all. That will be another way you can select everything. And then in here, we're going to set the type of move where we want to move it. So I recommend using the absolute and reference from the lower left corner as your anchor point. So this will now put the lower left corner of this design exactly where you specify here for the X and Y position. So X is going to be left to right. Y is going to be top to bottom. So I know I'm going to put some clamps around the edge. So I want to stay away from the edge enough so the tool does not crash into the clamps. That's going to be very important. So I'm going to type in here, say 1.5 inches for the X position. And then the Y position, we can do the same, or I can go a little bit less because I know there might not be a clamp there. So I'm going to type in 1 inch for the Y. And if we zoom back out and click apply, that will now move this. So now the very left corner down here is 1.5 inches from the X direction, left to right, and 1 inch from the bottom here. That should leave me enough room around here for some clamps, because I know I'll have a clamp over here somewhere. If you're worried about it being too close, you can also move it a little bit further if you wanted to. Other than that, we can now click close, and we can click the save button one more time to save that change. And now this has been completed for everything we need to do to design this. Of course, there's lots more you can do with this, but to keep this simple, we'll leave it as is. And in the next stage, we're going to be creating the toolpaths.
Now that the design is finished, we have the basic vectors we need for this project. We have the outside shape of the tray, the inside area that will become the recessed pocket, and the initial carved into the bottom. But right now, this is still just a design. The CNC machine does not cut the design directly. We need to turn this design into toolpaths. The toolpaths are what tell the CNC what bit we're using, how deep to cut, what areas to remove, and how to move around the project. For this beginner project, we're only going to be using 2 toolpaths, a pocket toolpath and a profile toolpath. The pocket toolpath will remove the area inside of the tray and carve the initial, and then the profile toolpath will cut around the outside of the shape. So now let's move into the toolpath side of Vectric and get this project ready to cut.
So we're back in the software, and we're going to be continuing where we left off with our design. And like I mentioned, on the left side of the screen is all of our design tools. But now we need to go over to our toolpath side to get to our toolpath tools. There's a few ways you can get there. There's keyboard shortcuts. There's a button up here at the top of the design tab to switch over there. You can also click on toolpaths up in the upper right corner, or you can click the toolpath drop-down menu and click show toolpath tab. Those are several different ways you can do it. My personal favorite is just to click this button up here at the top of the design tab. It's a little arrow. And when you click on that, that's going to hide the design tab and show you the toolpath tab. And there's also an arrow at the top of this tab to switch you back to the design tab. So those arrows will bounce you back and forth to each tab. You can also click on the toolpath tab up here and click this pin button to show both of them at the same time if you wanted to. There's a lot of customization you can do here. There's even more you can do that we cover in other lessons, but we'll leave it at that for now. So let's hide that design tab and let's focus on our toolpath tab. So for this, there's a lot of options here, but we're only going to focus on these very first 2 toolpaths. The first one is the profile. The second one here is the pocket toolpath. Those are the only 2 toolpaths that we're going to use for this whole project. The other thing you have to confirm is your material setup at the top of the toolpath tab. So if you click on that set button, that's going to open up this material setup where you can confirm all the settings that we set up earlier. And most importantly here is the thickness of your material. Make sure that matches what you actually have. Make sure your 0 positions are where you want them. And the other thing to look at is down here where it says rapid Z-gaps above material and the home and start positions. Rapid Z-gaps above the material is how high the tool moves up when it moves over to the next toolpath. If you have this set really low and you have a clamp or something in the way, it could crash into it. If you have it set really high, it's going to spend a lot of time moving up and down and just waste some time. Also, it may be higher than your max limit allowed on your machine, so you might also get an error code from that. So I like to put it at 0.2 inches. It's a pretty reasonable amount. And then the home start position, this is where your tools will start from and where they will end at. So whatever numbers you have here is where your machine is going to move when it starts the toolpath and when it ends the toolpath. So typically you're going to have 0 for the X, 0 for the Y. We'll show you how to zero your tools in the next video. But the Z gap above material, that one's important. Once again, you don't want it too high and you don't want it too low either. So for this, I generally put 0.8 inches. That usually works out pretty well. You can always adjust these numbers depending on your machine, but if you try these out, they should work out for you as long as your machine has the clearance for that, which most do. So that's all we need to do here. Once you confirm everything, you can click OK. And now we're ready to start creating the toolpaths. So to do this, we also have to think of the order of which we want to cut these in. Now, the profile toolpath, cutting the shape out, generally you're going to want to cut that last because that sets the part free. And if the part's free moving around, you're not going to be able to machine the inside. So it's always best to machine the inside first and then work your way to the outer profile. And then another thing to consider is the initial is at the bottom of this first pocket. So if we try to engrave the initial first, we're going to have to machine through all of the material above it. That's not what we want to do either. The order I would cut this project in is the bigger pocket first, then the initial for the letter second, and then the outer profile last. So there'll be 3 toolpaths that we set up for this project. Let's go ahead and set up our first one. And the other thing we have to do here is select the vectors that we want to associate with this toolpath. So for this first toolpath, we're just going to select this inner shape that we use the offset tool for. That's going to be the outer boundary of the pocket that we're going to machine in that area. You're going to select that shape, and then we're going to click on the pocket toolpath, which, like I said, is the second one at operations. From here, it's going to give you a lot of settings, and this is where it can get a little bit overwhelming. So just follow through with me and I will walk you through it. It's not as complex as it looks. So basically we need to set up how deep we want to cut this pocket first. And there's 2 different options here, start depth or cut depth. We're going to talk about start depth in our next toolpath, so I'll skip that for now, but we're going to start that out at 0. That's starting right at the top surface of our material. Our cut depth is going to be how deep do we want this pocket to be. This can be whatever depth you want it to be as long as it's not greater than the material thickness. If it's greater than the material thickness, it's going to start cutting into your spoil board. So you have to be careful of that. It will give you a warning, so that will be helpful as well. For this one, I'm going to cut it halfway through our material, which in this case will be 0.5 inches because I'm working with 1 inch thick material. If you have thinner material, you might want to adjust that a little bit less, but you can decide how deep you want to cut this. Up next, you can select your tools. And as you can see, it says tools and it has a list here where you can add multiple tools. In this case, we only need 1 tool. You could add multiple tools if you wanted to, if you have really detailed areas where you want a small tool to get into and really big areas where you wanted a big tool to go into, just to save you time on machining. But in this case, we're going to use 1 single tool. So if you have any tools in this list, you want to select them first and then click the remove button. That will remove them from your list. You should be starting out with a blank selection like this. So now we click select. And when you do that, it will open up your tool database. Now, if you haven't set this up yet, that's okay. Vectric has some default tools in here that you should be able to work with. You should find a group that says end mills, and there should be one that says end mill 1/4 inch. So that's the one I'm going to select for this project. And these are the exact settings I'm going to use. Once again, this is a part that's a little bit overwhelming for some people. So if you're not sure about these yet, don't worry. We'll cover these in greater detail later. But just to keep things simple for now, you can copy my settings that you see here. And basically the diameter of the tool is 1/4 inch. Number of flutes is 2. If yours is different, you can adjust it. And then for the pass depth, this will be how deep per pass we're going. Since this is foam, you can do in much greater pass because this material is very soft and won't break your bits. If you're cutting hardwood or anything harder than this foam, you're going to want to be a little bit more conservative with your settings. So keep in mind, everything I'm showing you here is applying to this foam. You're cutting a different material, maybe adjust it a little bit more conservative. So for this foam, I'm going to cut a 1/4 inch deep per pass. So that's where I'm going to set my pass depth. Next is step over. That's how much your tool moves over when it's cutting the pocket. This I would just put at 40%. Like I said, we'll cover this in greater detail later, but you can just match that for now. And then for our settings down here, these are pretty common settings here. We can do spindle speed 18,000, feed rate I'll do 60, and plunge rate 30. That should work out for most machines, especially hobby level machines. If you have a more industrial machine, you can most likely go a lot faster. Even some hobby machines can do a lot faster than this, especially in foam. But just to keep it conservative for any beginners out there, we'll use these numbers getting started. You can also check with your tool manufacturer for the recommended feed and speeds for that particular tool that you have. Once we have this all set up, we're going to click apply to apply all those changes and then click select. I will now select that tool and add it to our list here. You can always edit this again if you want to change the settings later. So now we go down to the next section. You can see number of passes is 2. That makes sense because we're cutting a 1/2 inch deep and we set it a 1/4 inch deep per pass. So 1/4 plus 1/4 will be 1/2. That's 2 passes it's going to make. And then next is our strategy. We'll cover these in greater detail as well, but just for this project, I'm going to use offset. That'll keep it nice and simple. Raster does work out really well to keep your toolpath marks out of hardwoods, but offset is a nice, quick, easy option as well. And then you can select your cut direction. You have climb and conventional. If you don't know what that is, basically it's clockwise versus counterclockwise, depending on how you're machining this. And a lot of times I find conventional works out really well. So that's one I'm going to choose, but you can experiment with this as well. For the foam, it's not going to matter as much. Up next, we have a ramp option. I highly recommend adding in a ramp because that will enter the tool at a little bit of a ramp at an angle rather than straight down into the material. Especially if you're cutting harder material, when you plunge straight down into your material, that's pretty rough on your tool and could cause it to break or mess up something. So it's better to add a ramp, which will slowly ramp it in. That way it's a little bit easier on the tool as it's going into the cut. So a good rule of thumb for ramp distance is double the diameter of your tool. That's the rule I use. That makes it really easy to figure out a distance. You can set it bigger or smaller than that if you want to. You can experiment with it, but just to keep it simple, I make it double the diameter. In this case, I'll make it 1/2 inch since I'm using a 1/4 inch tool. And that's it. There's a pocket allowance. That's just if you want to make the pocket a little bit bigger or a little bit smaller than your shape. But in this case, we don't need to do that. So we'll leave it at 0. And that's all we need to do. The last thing we have down here is your name of your toolpath. The better you name these, the easier they'll be able to find later, especially when you save the toolpath, you'll be able to find these easier. So if you just leave it pocket 1, 2, 3, 4, and you have, let's say 20 pockets, it could get confusing which one is which. So we can name this pocket, and I also like to put the tool in here. So I'll put 1/4 inch end mill. And some CNC controllers do not like special characters, or they also don't allow for a longer name. So you may have to get creative with your name here, depending on what controller you have. There's only a select few that do that, so most of them should be okay. The other thing I like to do is put a number in front of this. This will be the number of the order I will cut these in. This will be the first toolpath I cut, so I'll put number 1, and then I like to put an underscore there. That's going to be my name. Like I said, the name is just your personal preference. You can name it however you want to. Now we're going to click calculate, and when we do that, it's going to automatically generate a toolpath and take us to our 3D view. If it didn't do that, you can go to the 3D view manually and open up your preview toolpath if that didn't open up. As you can see down here, you can zoom in. You can also right click your mouse and move it around to twiddle your view and see different views of this. You can also use the cube up here in the top right corner to be able to play around with the view of this that you're looking at. You can see this red line is where it's starting from. This is going to be our rapid movement over to the center, and then it's going to drop down and ramp in there and start to cut from the center, working its way out. And you see 2 rows of lines there. That's both depth per pass. So we have one depth at a 1/4 inch and a second depth at a 1/2 inch. And then what you can do here is click preview selected toolpath. And when you do that, it's going to preview it. As you can see, it previewed very quickly. So what I recommend doing is clicking reset preview. And there is this speed slider here. I like to drag that down a little bit and then click preview again. And now you could see it a little bit slower so you can see exactly what's going to happen here. It's always good to zoom in real close, slow it down, and get a good preview of what's going on, because when it previews really quick like that, you can miss something really critical that may cause an issue later. It's always good to keep an eye on this. For this project, it shouldn't be any problems, but you never know what kind of problems you may run into in a future project. And then once you're happy with it, you can also speed it up. And if you're confident it's going to work out just well. Also, you may see it's a little bit blurry if you zoom in really close. You can fix that by going up to Toolpaths at the top and then going to Preview Simulation Quality, and you can turn this up. This just turns up the quality of the 3D view. However, it does slow down your computer a little bit, so you can experiment with that as well. I'll just leave it at standard for now. Okay, so that will now preview the first one. Now we need to create our second toolpath, and that's going to be for the initial. So what we're going to do is click Close on our preview, and then we have to select our next letter. If you're in the 3D view and you have your 2D vectors turned on, you can just stay here and select that. If you're not here, you're going to have to go back to the 2D view and then select your initial and then go back to the pocket toolpath. You could do it in either the 2D or 3D view. We're going to click pocket toolpath, which is our second option again. And this will remember everything we used in the last time we set this up, which was just now. So all the settings we just used, it copied them over here to use again. But in this case, we're going to change it just a little bit. Everything else is mostly going to stay the same. The only thing we're going to change up here at the top is our cutting depths. So like I mentioned, the start depth and cut depth are a little bit different. So if we look at our final project here, we already made away this big pocket in the middle. So now the surface of the material has been removed, and now we're a bit lower inside of the material. So that's going to give us a new starting depth. So the depth of that pocket is going to be the depth of our start depth. Basically what that means is, where do you want to start the tools to machine from? So I'm going to start it at that 1/2 inch depth that we set for our previous pocket. So if you set a different depth for your pocket, you can adjust that according to whatever depth you set there. Now the cutting depth is how much deeper you want to go past that starting depth. And in this case, I'm going to put a very shallow pocket at the bottom. I don't want it too deep because I don't want things getting into that pocket and getting stuck. I'm just going to make a really shallow pocket there. But for this, I'm going to put 0.05, which is a very shallow cut there, less than a 1/16 of an inch. You can adjust that if you want to, but that should work out just fine for this project. And that's all we need to change on this project. You don't have to change anything else. We already have the tool selected, and we already have all the strategies and everything selected. Now you may be wondering about the pass depth that we set earlier. If the cut depth is less than your pass depth, it'll automatically default to whatever the cut depth is in one pass. And as you can see, number of passes is 1. So that's going to work out just fine. And then last thing we're going to do down here is where it says the name. We're going to name this number 2 underscore, and we can name this pocket initial. And I'm going to put 1/4 inch end mill. And then I'm going to click calculate. And that's now going to calculate that toolpath for that letter. And once again, you can zoom into that and look around, and you can see it's going to rapid move over here, drop down, ramp into the cut, and cut out that letter. And it's going to do one little spot here as well to make sure it removes all the material there. So I'm going to slow down the speed again, and I'm going to click preview selected toolpath. As you can see, it's just doing a very shallow cut at the bottom there. I'm going to show you real quick why the order of toolpaths really matters here. Because if I reset the preview, and if I were to preview that toolpath first, you can see it's cutting very deep. And if I preview that, you can see there it is, cutting really deep in one full pass. And if you're cutting into a really hard material, that could possibly break your bit, because it did that all in one full pass. So that's why it's important in the order that you machine these. So we're going to do the pocket first, the big pocket, and that's going to preview. And now that removed all that material away. So now the smaller initial pocket is going to machine at the bottom there. And that's looking really good so far. So now there's only one more step for this, and that is to cut it out with our profile toolpath. So we're going to click close on this again. And once again, we're going to select the outer shape. I'm going to do it in the 3D view this time. If you don't see it here, you can also go back to the 2D view. So for this toolpath, we're going to go ahead and select the first one called Profile Toolpath. When you open that up, there's going to be a lot of options in here if you have this Show Advanced Toolpath options turned on. I recommend turning that off if you're new. That way it shows you a lot less options and it's a little bit less overwhelming. We'll go deeper into all those options later, but for now, we'll keep it nice and simple. So for this one, once again, the cutting depths are exactly the same. We're starting at the surface of the material, so we're going to start with the start depth of 0. And then the cut depth you want to cut through, in this case, I'm going to cut 1 inch deep. That's going to go all the way through the material. Some people like to cut a little bit extra to get into their spoil board a little bit to make sure they cut all the way through. I personally don't like to do that. I like to just set it the same depth as the material. So adjust that whatever you want it to be able to cut through your material. Up next is our tool. If you don't have a tool selected here, you're going to click the select button and you're going to choose the same tool that we used in the previous toolpath. It's very important you use the same exact one because we're going to be using that same tool for all 3 of these toolpaths and we're going to save it all together. If it had a different tool number or something's different, it may not let you save them together. It may treat it as a different tool. So make sure you select the exact same one. The feed and speeds can be different, but the main thing that has to be the same is the geometry and the tool number. So those are the only 2 things that need to be the same. Now we're going to click select, and now we're going to set how we're going to machine these. So where it says machine vectors, we're going to cut on the outside of the line. That'll make sure it cuts it to the exact size that we made it. If you did it on the inside of the line, it's going to cut on the wrong side and it's going to be too small. And same thing, if you cut it on the line, it's going to be halfway across on both sides. So I'm going to cut on the outside of the line. And once again, our direction, I'm going to choose conventional. You can experiment with that if you want to. Then once again, we're going to add a ramp to ramp our tool into the cut. And I'm going to make it a 1/2 inch distance. Now, the last thing I recommend you do is add tabs. In the video we have coming up where I actually cut this project out, I did not add tabs and the part actually moved on me at the end. You'll see that in our next video. So to avoid that happening to you, I highly recommend adding tabs because that will hold it in place. And then you just need to cut those tabs out afterwards with if you're using foam, you can just use a sharp knife to do that. Or if you're using wood or something, you can use a multi-tool or something like that to cut the tabs. But that's going to be very important to hold the part in place. And there's just a little bit of leftover material it adds in there, sort of like a bridge connecting it to the original material. So I'm going to click that option to turn it on. And for the size of these, they don't have to be super big, but you don't want them too small either. So the length I'll make 1/2 inch and the thickness, let's make it 1/8 of an inch, should be fine. And you can always change that if you wanted to. And now we have to click this edit tabs button because right now we don't have any tabs placed on here. So if you click edit tabs, this is going to ask you where do you want to place them. You can either manually click on the line to place them in the exact locations, or you can use this form here to automatically add them for you. I would avoid putting them in an internal corner because that makes it a little bit harder to remove them later. If you can put them on a nice straight area or an external area, this will make it easier to remove later. So I like to put it in a nice flat area because that's usually easier. In this case, I would put it on the outside of this corner because you can sand that off pretty easily, especially if it's a wood. So I would probably just left click on all 4 of those corners like so to add tabs there. Like I said, you can use this form if you wanted to, but I like to just click where I want them. You can always click on them again to remove them, or you can click and drag them to move them to a new location. That's something you could do on your project. 4 should be plenty to hold this. You can do a little less if you wanted to, but I wouldn't go overkill because the more you add, the more you're going to have to remove later. Now I'm going to click close, and that's it. Now we just need to set up a name. So I'm going to put this as number 3 underscore, and I'll name it profile 1/4 inch end mill. And then we're going to click calculate. And that's now going to calculate the toolpath to machine this out. Now, the one thing I see is it's more number of passes than what I wanted here. And if we go back to that profile toolpath, if you ever want to edit something, you can always double click on it to edit or right click on it and click edit. That will open it back up. And if I click edit on the tool, that's going to open up our tool database. And here I can see the pass depth is using the old one I didn't want. So I'm going to remove that and put it back to 1/4 inch. And I think it used all my old settings because I already had that tool selected. So it just defaulted back to my old settings. So I have to just adjust this back to where we were on the previous settings. And that's why it's always good to double check things. So now it looks good. I'm going to click OK. And I'm going to click calculate again. And you'll see that will now update it when you do that. Anytime you make a change like that and you calculate it, it will now change to those new settings. So as you can see, this is 4 passes. And the bottom pass, you can see where it's skipping over some areas for the tabs. And over here is our ramps. So we are going to preview this. So I'm going to slow down again and click preview selected toolpath. As you can see, that's going to go around and cut this project out. And when it gets to that final pass, it's going to leave those tabs holding it in place. Now we have 4 tabs in those corners, and this project would now be complete. Of course, you can do more to this if you wanted to, but this will be the simple project that we're going to make. And then if you're using foam, you can use a nice sharp knife and cut those tabs away. Or if you're using wood, you could use like a multi-tool or a bandsaw or something to cut those away and then sand them down. But that will now be our finished project. So now we need to get these instructions to our machine. So to do that, first what I like to do is click File, Save, to save our project file. This will be a project file that we can go back to later if we need to edit anything. And then we need to save the actual Gcode files that is going to be the list of instructions for our machine to follow. So to do that, we're going to click Close on our preview, and that's going to be this last button here in the Toolpath tab. And it's going to be Save Toolpath. You're going to click on that, and that's going to open up this form to save your toolpaths. So the first thing we want to do is click Visible Toolpaths to one file. That means all the toolpaths that we select, it's going to save them all to one file. And that will work as long as the tool is the exact same. Or if you have an automatic tool changer, if you're using different tools. So keep that in mind. You may get an error message if you use different tools and you don't have an automatic tool changer. In this case, we're using the same tool, so it won't give us any errors. So in order to have them saved, you can see right now there's no visible toolpaths. So we have to check the box down here where it says toolpaths. We can click that checkbox there to select all, or you can manually select the ones you want to save. In this case, we're going to do all 3 of those. And now you can see where it says toolpaths to be saved, it has all 3 of them there. And this is the tool number here, number 1. If you had an error message, there may be a different tool number for these. So you might have to edit those to fix that. But now the next thing we need to do is check our machine down here. This has to match the machine you're using and the post processor that you're using. If you didn't set this up yet, this will now be a good time to set that up. Basically, you can click this edit button if you haven't added one yet. And then you're going to click the button up here to search online for a machine if you're connected to the internet. And then you're going to go through the prompts there to select the machine that you own. And it'll have a big list of manufacturers that you can select from. So if you don't have that set up yet, I would follow those steps to do that. As you can see, there's a big list here you can select from. Now, I already have this set up. So what I'm going to do is drop down this machine. You can see I have several different ones loaded up here. I'm going to choose the one I'm using here, which is the Elite Redline Foreman. And then this one is going to be default. I'm not using rotary in this project. We're using just the regular 3-axis. So you're going to use the default option. And then where it says post processor, we have to make sure we select the correct post processor. So it'll be the one connected to that machine. You can either do inches or millimeters. We're doing this project in inches, so we're going to select that. You can use millimeters or inches, vice versa. It will automatically calculate for it. But just to keep things from messing up, I'll keep it in the same format we have our project. And that's it. Now we're just going to click Save Toolpaths. And that's going to open up your file menu. And what I recommend doing is getting yourself a USB drive or whatever you can connect to your machine to save your file to. So we're going to plug this USB into our computer. So I just plugged the USB into our computer, and then I'm going to find that in this PC, and then you can scroll down and you can find the USB drive. You can double click on that to open it. I don't have anything on this, so I can just save it here. If you have things in here, just make sure you keep things organized where you can find this file. This file is going to be in a Gcode format. It's going to be like a text file. And I'm just going to name it initial tray. You can name it something else if you wanted to. This will automatically take the name from our project. So that's why it entered in there automatically. But if you want to name it something else, you can. You can also give it a version or a date that you saved it, because sometimes you may save several different versions of this. So make sure you can go back and find the one you're after. And I always recommend these Gcode files to be temporary files. I'm going to delete this file later once I'm done with it, because next time I cut this project out, I might not be starting with the exact same setup. I still have the project file I can quickly save this Gcode file from again, but I always like to delete my Gcode files when I'm done with them, because they're not always the same every time when you're running this again in the future. Keep that in mind. You can reuse it as long as everything else is exactly the same as the first time. So I'm going to click Save. And that has now saved that to my USB drive. I can now unplug that and take it over to my machine.
Now we have our toolpaths created and previewed inside of Vectric. One of the most important habits to build using Vectric is to always preview your toolpaths before taking them to the CNC. The preview gives you a chance to catch any mistakes before you cut your material. Once the preview looks good, you can save the toolpaths using your correct post processor for your CNC machine, and then we can take that file over to the CNC and actually cut the project out. For the machining portion, keep in mind your machine and controller may look a little bit different than mine. I'm using the Onefinity Elite Gen 2 with a redline controller. So the exact buttons and menus may not match your setup, but the basic process is what I want you to pay attention to. We're going to secure the material, install the bit, home the machine, set our 0 location, load the file. We're going to run a ghost toolpath. Then we're going to set the Z0 correctly and then actually cut into the project. So let's head over to the CNC and make this project. The first thing we need to do is secure our material to the CNC table. For this project, I'm using a simple piece of insulation foam board. This is a great practice material because it's inexpensive, easy to cut, and much more forgiving than wood. You can use wood if you want to, but if this is one of your very first projects, foam is a great way to build confidence without worrying as much about breaking a bit or ruining a nicer piece of material. For my setup, I'm using T-tracks and simple clamps to hold the foam board down. Your setup may be different, and that's completely fine. You can use clamps, screws, double-sided tape, a vacuum table, or another hold-down method, depending on your CNC and material. The main goal is to simply have the material held down firmly so it cannot move while the CNC is cutting it. Here you can see one of the corners of the foam board is lifted up a little bit. Even though the rest of the material looks secure, this corner can still move up and down. This is a very easy way to mess up a project. If the material lifts, shifts, or vibrates while the CNC is cutting, the cut may not come out correctly. In some cases, it could also cause the bit to grab the material or damage the project. So before running the job, always check your material and make sure it's held down firmly. Here I am adding another clamp in that corner so the material is more secure. Just make sure not to put any of the clamps in the way of your toolpaths. This is one of those simple steps that can save you from a lot of frustration later. Next, we need to insert the bit into the collet. For this project, we're using one bit for everything, a 1/4 inch end mill. Since we're only using one bit, we do not have to worry about tool changes, which helps keep this project much more beginner friendly. When inserting the bit, you do not want it barely held inside the collet. If the bit is only inserted a small amount, it may not be held securely enough, and that can be dangerous. But you also don't want to push the bit too far into the collet, where the cutting flutes are inside the collet. And the flutes are the cutting part of the bit, and the collet should be gripping the smooth shank of the tool, not the cutting edges. A good setup is to insert the bit far enough into the collet so it's held securely, but still leave enough of the bit sticking out to cut through your material. For this project, I'm positioning the bit just above the cutting flutes, while still leaving enough cutting length below the collet to machine through the foam board. Once the bit is positioned correctly, tighten the collet securely, but do not over tighten it. After the bit is installed, the next step is to home the machine. Homing tells the CNC where it is located in its machine travel. On this controller, I can press the Home All button and the machine will home the X, Y, and Z axis. Not every CNC has this exact feature, but most CNC machines have some type of homing process. In most cases, this is something you should do after turning on your machine, so the controller knows where the machine is located. Once the machine has been homed, you usually do not need to home it again until you turn off the machine and back on. Again, your machine may be a little bit different, so follow the instructions for your specific CNC. Now I'm jogging the machine over to the lower left corner of the material. This matches the XY0 location that we set up in Vectric. When you're setting the XY0, remember that the center of the bit should be lined up with the 0 point. You're not lining up the edge of the bit, you're lining up the center of the bit. For this project, I'm just eyeballing the position because the XY0 location is not super critical for this particular project. Since we're cutting out the final shape, we just need to make sure the project fits on the material and is positioned close to where we expect. For some projects, your XY0 may need to be much more precise, but for this beginner practice project, close is good enough. I'm also raising the bit above the surface of the material. The reason I'm doing this is because I want to run the toolpath in the air first, almost like a test run. I like to call this a ghost toolpath. Instead of cutting into the material right away, we can run the same toolpaths above the surface and watch how the machine moves.
This is optional, but could be really helpful if you're nervous about running a new project. If your machine does not have enough Z clearance to run the toolpath above the material, another option is to run the project without the material on the machine, just so you can watch the movement first. The goal is to build confidence and catch anything that looks wrong before the bit touches the material. Once the machine is positioned where we want our 0 location to be, we need to set the work 0. On this controller, I'm clicking the 0 all button. This tells the controller that the current position on the machine is our 0 location for this project. This is very important because all of our toolpaths will reference from the 0 point. In Vectric, we set up the project using the lower left corner as the XY0 and the top of the material as the Z0. So the CNC needs to match the same setup. For the ghost toolpath, we're temporarily setting the 0 higher above the material so the machine can run through the motion without actually cutting. Later, we'll set the Z0 correctly to the surface of the material before running the actual cut. Next, I'm plugging in the USB drive into the controller so we can load the Gcode file. This is the file that we saved from Vectric in the previous lesson. Now I'm using the controller menu to find and open the Gcode file. Again, every controller interface will look a little different. You want to load or open the file, review that the correct file is selected, and then get ready to run the job. Before starting anything, always double check that you loaded the correct file. This is a simple habit that can prevent a lot of mistakes. Before starting the toolpath, make sure you know where your emergency stop button is. On this machine, the e-stop is right on top of the controller. You should always know how to stop the machine quickly before you start running a job. I'm also twisting the e-stop button to make sure it's not pressed in. If the e-stop is engaged, it may prevent the machine from running or cause an error on the controller. Before pressing start, also make sure that the area is clear, the clamps are not in the cutting path, the bit has enough clearance, and there's nothing loose on the CNC table. Now I'm starting the toolpath, but remember, this first run is our ghost toolpath. The machine is moving above the material, so it's following the same toolpath without actually cutting. Some machines will control the spindle or router automatically and some will not. If your spindle or router is not controlled by your CNC controller, you may need to turn it on manually before starting the toolpath. This ghost run is a good time to figure that out, because you can see how your machine behaves before cutting into the material. Let the ghost toolpath run all the way through, watch the movement of the machine, and make sure it looks like it's doing what you expected. If something looks wrong, this is the time to stop and fix it before running the real cut. This is a great confidence building step, especially when you're still getting comfortable with your CNC. Now that the ghost toolpath is complete, we need to set up the Z0 correctly to the surface of the material. In Vectric, we set the Z0 on top of the material, so we need the CNC to match that. For this machine, I'm using a probe to set the Z0. If your machine does not have a probe, you can also manually jog the bit down to the surface of the material and set the Z0 that way. On this controller, I'm using the probe Z option because we already set our XY0. We only need to update the Z position. Now I'm jogging the machine over to the probe. The probe needs to be positioned under the bit so it can touch it during the probing process. And next, I'm connecting a magnet to the collet nut. This completes the circuit for the probe. Before starting the probing process, I'm touching the probe to the bit to confirm that the probe is working correctly. This is a very important step. It confirms that the controller can detect contact between the bit and the probe. It also helps prevent the machine from pushing the bit down into the probe and causing damage. This also confirms that the bit is conductive and will work with the probe. Once we know the probe is working, I can start the probing process. The tool lowers down and touches the probe. On this machine, it touches off twice to confirm the Z0 location. One important thing to remember is that your controller needs to know the correct thickness of your probe. That probe thickness is what allows the machine to calculate the actual surface of your material. If the probe thickness is not calibrated correctly, your Z0 may be wrong. So make sure you follow your CNC manufacturer's instructions for setting up and calibrating your probe. Next, I'm adding the dust collection boot over the bit. For this project, we're cutting foam, so it's a good idea to use a dust collection to help keep the work area clean. On this dust boot, I can use different bristle lengths depending on how far the bit sticks out and how much clearance I need. The goal is to get good suction around the bit without interfering with the material, clamps, or machine movement. For filming, I'm going to remove the bristles so you can see the bit cutting more clearly. But when you're cutting your own project, I recommend using dust collection wherever possible. Now we're ready for the fun part of running the actual toolpaths. Before pressing start, do one more quick check. Make sure the material is clamped down securely, make sure the bit is tight, make sure the correct file is loaded, make sure the 0 location is set correctly, Make sure the dust collection is ready and turned on. Make sure your spindle or router is ready to turn on, and make sure you know where the E-stop is. Once everything looks good, we can start the job. This time, the bit is going to cut into the material. The first toolpath is the pocket toolpath for the inside of the tray. This will remove the material from the inside of the area and creates a recessed pocket. After that, the machine cuts the pocket for the initial at the bottom of the tray. This is what personalizes the project and makes it feel like your own. Then the final toolpath is the profile cut around the outside shape of the tray. This separates the finished project from the rest of the material. For my version here, I did not include tabs, so you may notice the part moves a little bit when it's being cut free. You will see that coming up soon. In the toolpath lesson, I show you how to add tabs, and I recommend using them so your project stays held in place during that final profile cut. Tabs are small pieces of material that hold the project in place until the cut is finished. Then you can remove the project from the material and clean up the tabs afterwards. For now, I'll let this run and you can watch the toolpaths cut out the project. And here is the finished foam version of the tray. This is a simple practice project, but it gives you a complete start to finish workflow. You can use this as a small tray for items like paper clips, spare change, keys, or other small things on your desk. You can also use it as a coaster for a drink. And here I'm showing another version made from hardwood in a circular shape. This is a great example of how you can use the same basic process and change the shape, material, size, or letter to make all kinds of custom trays and coasters. You do not have to be limited to basic rectangles or circles. One of the best parts of having a CNC is that you can create custom shapes that would be difficult to make with regular woodworking tools. So once you understand this process, you could start making the project your own. And that is the full process of creating your first CNC project. Even though this was a simple project, this is the same basic workflow you will use over and over again with your CNC. Design the project, create the toolpaths, preview the toolpaths, save the file, set up your CNC, set your zero locations, and run the job. Once you understand that process, the CNC starts to feel a lot less overwhelming. And remember, your first project does not need to be perfect. The goal is to learn the workflow, build that confidence, and get that first win. If you want to learn more about using Vectric and you want a step-by-step path to go from beginner to confident, make sure you check out our Vectric Master Training course. We've had over 7,000 people across the world take this course, and they've made so many amazing projects from this course. Inside the course, we go much deeper into 2D design, toolpaths, project setup, text, layers, importing files, creating custom projects, and much more. If you like this video and want a more complete training path, you can check out the Vectric Master Training course using the link in the description, or you can scan the QR code on the screen. Also, if you make the project from this video, I'd love to see it. Post your picture of your finished project and tag us, or share it with our Learn Your CNC community, link down in the description. Thanks for watching, and I will see you in the next video.